Good morning to one and all. Myself DS Gordhan. I'm from Triple second year. My topic is about cooling of power transformer dismissions. First of all, content in this topic from introduction, method of cooling, applications, and conclusion. First of all, introduction. Power transformers are key components for electricity supply systems. It converts energy at one voltage level to another voltage level. During the process of energy transfer, losses occurs in the windings of the transformer. These losses appear as heat that may burn the winding of the transformer. So to make the transformer healthier, cooling is needed. First of all, methods of cooling. Coolings are two types: air type and oil type. Oil type. Air type cooling. Air natural AN cooling. Air blast cooling. And oil immersed type. Oil natural ON cooling. Oil natural air forced ONAF cooling. Oil natural water forced ONWF cooling. Oil forced air natural OFAN cooling. Oil forced air forced OFAF cooling. Oil forced water forced OFWF cooling. And next, air natural cooling. The transformers have smaller output, 5 to 10 kilowatts, kilowatts, are cooled by this method. In this method, the external surface is sufficient to dissipate the heat produced by losses. Such transformers are cooled by the combination of air convection currents within the enclosed case and by natural radiation from this case itself. Here we can see the practical view of AN cooling. And next, air blast cooling. This type of cooling is used in dry type transformers. In this method, heat dissipation is improved by a continuous blast of air force through the core and windings. The air blast is produced by means of external fans and blowers. This type of cooling is limited to transformers of voltage rating not exceeding 25 kilowatts. And next, this one, disadvantages. In this process, the increase in insulation strength is not obtained due to non-immersion in oil. A regular maintenance is a must for this kind of transformers. That is filter maintenance. Oil natural ON cooling. This is the most usual methods of cooling. Here the assembly of core and windings is immersed in insulating oil contained in iron tank. The heat produced in core and windings passed on to oil by conduction. Oil in contact with the heat parts rises and its place is taken by cool oil from the bottom. The heated oil transfers its heat to the tank surface, which dissipates into it to the surroundings. Operation of oil natural ON cooling. Practical view of ON cooling. And next, oil natural air forced ONAF cooling. Here the assembly of core and windings is immersed in insulting oil and cooling is improved by forced air over the cooling surfaces. The air is forced external such as the case tubes and radiators, usually by means of fans mounted external to the transformer. Medium to large capacity transformers are cooled by this method. And next, practical view of ONAF cooling. And oil natural water forced ONWF cooling. In this type of cooling, the core and windings is immersed in an insulting oil and cooling is improved by circulation of water through copper cooling coils mounted above the transformer core but below oil surface. The heated water is cooled in a spray pond or cooling tower. This method will be cheaper where a natural water head is already available. Oil forced air natural cooling OFAN. In this method, oil is circulated through the transformer with the help of pump and cooled in a heat exchanger by natural circulation of air. This method proves very useful where coolers have to be well removed from the transformer. This method is not very common. And next, oil forced air forced OFAF cooling. In this method, oil is cooled in external heat exchanger using air blast produced by fans at light load, say up to 50% of rated load. When the losses are small, natural circulation of air may be sufficient to cool the transformer. At higher loads, the pump and fans may be switched on by transformer temperature sensing elements. This arrangement results in higher efficiency of the system. And next, operation of OFAF cooling. It is the diagram of oil forced air forced cooling. And next practical view of OFAF cooling for of transformer. And next oil forced water forced OFWF cooling. In this method, the heat oil pumped out from the main tank to the radiator, where the oil is cooled by the water passing through copper tubes. The pressure of oil is kept higher than that of water. Therefore, any leakage that occurs is from oil to water. There is no condensation problem. And next, nitrogen cooling. Heat transfer analysis on a cryogenic cooling system is performed for HTS transformers to be operated at 63 to 66. Okay. HTS windings are immersed in a liquid nitrogen bath. HDS windings are immersed in a liquid nitrogen bath where the liquid is cooled simply by colder copper sheets vertically extended from the cold head of a cryocooler. Liquid nitrogen in the gap between the windings and the copper sheets develops a circulating flow by buoyancy force in subcooled state close to the normal freezing point. Nitrogen functions Nitrogen functions as heat transfer medium and electrical insulting fluid at the same time. Continued. HTS winding in a main cryostat filled with a subcooled liquid nitrogen at around 65 Kelvin, 65 K, and located an iron core through room temperature bore of the cryostat. The subcooled liquid is continuously chilled by two sets of cryocoolers in a secondary cryostat and circulated through transfer lines to the main cryostat by a pump. And next, LN2 subcooling for core and coil assembly. It is a diagram. And advantages: faster thermal cycles, lower temperature limits, minimal maintenance costs, small equipment, and lower electricity usages. And applications: in natural air cooling is used for smaller output transformer having rating 5 to 10 kVA. Air blast cooling is used for dry type transformer. The voltage rating should not be exceed 25 kV. The air force OFAF cooling is usually used for power transformers of rating 30 MVA and higher. And next, oil forced water forced OFWF cooling is used for transformers designed for hydroelectric power plant. Cooling radiator system with natural cooling is used for power transformers with a capacity of 10 MVA. And next, conclusion. Not only the transformers but also all electrical equipment requires cooling system. By providing cooling system, the efficiency of the transformer will increases. In case of rotating electrical machines, due to rotating parts, air natural cooling is provided. But in case of transformers, there no is there no is rotating part. So these types of cooling must required for transformer. Thank you.